Hello students, my name is Vishal Kumar. So the topic we are going to study is Aldol condensation. So what we are going to study in the Aldol condensation is that what is Aldol that we are doing condensation of that, and what are the substrate that required for the Aldol condensation, and what are the reagents that are specific for the Aldol condensation. So the Aldol condensation is study for the carbonyl compounds. So carbonyl compound which shows the Aldol condensation are aldehyde and ketone which have alpha hydrogen. So what is alpha hydrogen? Let's take an example. So I am drawing a acetaldehyde. Okay, this is the acetaldehyde, you all know guys. So the carbon adjacent to that carbonyl carbon, this is carbonyl carbon, this is carbonyl carbon. Okay, this is carbonyl carbon. So carbon adjacent to the carbonyl carbon is known as the alpha carbon, and hydrogen attached to that, this is the alpha hydrogen. So what are necessity for the Aldol condensation is that your carbon should have the alpha hydrogen. So this alpha hydrogen are more acidic. ये acidic. These are acidic. So another reagent that we require here is your dilute NaOH or KOH, any alkali metal solution which is diluted in form, either it KOH or NaOH. So what they give OH minus. So this is basically a negative species, or we have said this is a base. What it will do, it attack the positive H plus ion. They attack here. It will donate its electron density to that H, and this whole electron density come to that carbon. So in the next step, the new species will be CH2 minus COH minus. So this new species form is nucleophilic in nature. Why this is nucleophilic nature? Because it contains a negative charge of the carbon. It's a carbon anion. So carbon anion, which is a negative charge, or any species which have containing a lone pair, are specifically known as the nucleophile. So what it will do, it will attack the positive species, the positive area. It will attack. It donates its electron density to the positive area, because that's why it's known as nucleophile. Nucleophile means loving species of a positive charge. So here in the same solution we have present another acetaldehyde molecule. Another acetaldehyde molecule is also present. So here oxygen is electronegative. It contains the negative charge. It abstracts the negative electrons towards itself, so it have a partial negative charge. Okay, and the carbon adjacent to the carbon, which is a carbonyl carbon, have delta positive. So our nucleophile will found this carbon as a nucleophilic. This is an electrophilic species, and this will attack this particular carbon. Why? Because it has a positive charge, and this species loves the positive charge because it is a nucleophile. Okay, in the next step, what will happen? It will attack to that carbon, and this electron density go to the oxygen, and the negative charge of oxygen will come simultaneously. So I am drawing the whole scenario. How is it will be bonded? See, this carbon is directly bonded to that carbon, and negative charge will go to the oxygen. So I am drawing you all this CH2. This is that carbon having the negative charge. So it will bonded to the carbonyl carbon, and that electron density goes to the oxygen having negative charge, and it have hydrogen attached, and another CH3 molecule is attached. Okay, and to that CH2 this CHO is aldehydic group is bonded to that CH2 group. Okay? This is the species that will form after the attack. This is the new species. Okay, so in the same solution, when this attack to that hydrogen, the water molecule releases. OH bonded to H, hydrogen and OH will form water molecule. So in the water molecule, from the water molecule, this is my water molecule. This O minus will abstract again H plus ion from the water molecule. Okay, so that's why we need diluted. If it's not diluted, the water molecule will not be presented. Okay, so this new species will be formed. Okay, this is the new species that will be formed. Now this is what we call aldol. The aldol condensation that we are studying, this is the aldol. Why this is aldol? Let's see that. It has the aldehyde group CHO. Okay, that comes from the ald, and the alcoholic group which gives the ol. So that's why the combination of both the functional group aldehyde and the alcohol will have a combination name which is known as aldol. So any species containing aldehyde and the alcohol group is known as aldol. Okay, in the next step, what happens when we provide the heat? When we provide the heat, what will happen? So here it having two hydrogens. When we are, I am writing is in this way. So when we provide heat, so after providing heat, there is a loss of water. That is known as condensation. The loss of water from the molecule is known as the condensation. So from there, water molecule releases. Water molecule releases from here. So this is the water molecule that releases, and simultaneously there will be a double bond making on the in between these carbons. Okay, so here the loss of the water, that is known as condensation. So this is the aldol, and from the aldol we are removing the water molecule by applying heat. So there is a condensation. This is the condensation. Removal of water from the species is the condensation. So condensation of what? Aldol. So after giving heat, so this particular type of species will form. Okay, so this particular species have another general form, general name basically. So what is the general name? Its general name is enol. Why enol? Because it have a double bond, and for double bond suffix uses en. Okay, and for aldehyde there is aldehyde also, and for aldehyde the suffix uses al. So the combination of both of these functional groups result this name as enol. So this is a enol. So we can say that in aldol condensation, what happens from taking an aldehyde or ketone, we result in the form of enol. So if we use ketone, we will have resulted in the final product of enol. Okay, so the short trick, I am giving you the short trick here also, how to do that. By not going to the mechanism, we can do directly shortly. Like take two molecule of acetaldehyde. I am taking the two molecule of acetaldehyde, CH3 CHOH. Okay, so this is the acetaldehyde one molecule. I am writing you this molecule in particular orientation so that it will be easier to understand by you guys. Okay, so this is acetaldehyde one molecule, and I am taking another acetaldehyde molecule having alpha hydrogen. This is the alpha hydrogens. Okay, this is the alpha hydrogen molecules. So what happened? This O and these two hydrogen combine. This O, oxygen, and two hydrogen result to form H2O. They will release as a body. So here we are seeing that H2O is releasing. Okay, and instead of that O and double H, the double bond between these two carbon will be formed, which is look like this. Okay, so this is the short way of doing the aldol condensation. This is the short way of doing the aldol condensation. So I hope you all understand what is aldol condensation, how to do in a smaller way or in a faster way, and how to expand it through the mechanism. Thank you so much for all being with me, and I hope you all doing in your better in exam. Thank you so much.